Hello! This video is a guide for the Arduino guided activity for reading temperatures using a temperature probe. If you're watching this video, it's really important that you've already constructed your circuit on your Arduino, have the temperature probe ready to go, because that is not going to be covered in this video. The point of this video is to take you through the guided activity and work through the programming. If you haven't done that, check back onto the guide through the shared folder and where you found all your resources so far. First thing we're going to want to make sure we're doing as we go forward is that you have the Arduino IDE. That's this window right here. This is available on the website, linked in the document. If you haven't downloaded yet, you need to go do that. Once we've got the interface, the first thing we want to look at is just all of the different features that are available and how to use it. When you first open up Arduino, you're going to get something like this. It's going to have a void setup, a void loop, and there's not going to be anything in it. It's going to have a default name. It's going to be the sketch and then whatever day it is. What we're going to look is just kind of hover over the buttons that are important to us and what we care about. So starting up top, we have this check mark. It's our verify. It's going to make sure we didn't make any errors in our program. If there's anything that's wrong, it's looking for something that we don't have. It's going to make sure it's correct. And we can test it without putting it on our Arduino. Next to it, we have this arrow. It's pointing to the right. It's our upload button. This is going to, default setting is it's always going to verify first, and then it's going to send it to our Arduino. And once it's been sent there, it's going to actually automatically run for us as well. There are a couple other buttons. There's new, open, and save. You can also hit all of these from the file menu. And then way over here on the right, we have something that's called a serial monitor. And what this is doing is it's monitoring communication between the Arduino and the computer. If I click that and open it up, right now, it's not too happy with me. It says board at COM3 is not available. What I need to check is using our tools menu is whether or not my Arduino is actually plugged in correctly. So I'm identified as an Arduino Uno, and right now the port is grayed out. So I'm going to check the connection on my computer and make sure we're actually connected properly. When you open up the tools menu, you're going to have a couple options. Here under board, I'm using an Arduino Uno, and I can see that it's selected. If you have a couple different types, you would want to match what Arduino you're using. And COM port should be the only active communication port, serial port you're using. Hopefully it recognizes it as an Arduino Uno. Windows 10 is generally pretty good at that. When those are correct, and I hit upload, what it's going to do is it's going to send code to out to my Arduino. Now, this is an empty sketch. It doesn't do anything. So it verifies that my communication is good between the computer and the Arduino, but it doesn't actually do anything. So it's not the most exciting, but I've made sure it works. There are a couple other things we want to do before we even start writing a program. The first thing we want to check out is do a few changes. It's going to help us during this activity, just helps you down the road. So under File, we have the option to go to Preferences. Here in Preferences, what I'm going to do is I'm going to make sure I've selected the box that says Display Line Numbers. There are a couple others that are optional, such as Enable Code Folding. I tend to make sure I actually use this. If you want to make the font bigger, you think it would be easier to see, you can also put in whatever font size you want. So when we hit OK, the numbers will have appeared here on the side for our line numbers, and I made my font a little bigger so it's easier to read. You can do whatever you need for that. But that will get us ready to start actually writing our program. What we want to do next is actually pull up our template file. So where this file exists on your computer is going to depend on where your downloads are set to default to. Most people, it's just going to be a folder called Downloads. So I'm going to find my temperature probe template that you should have downloaded from the resources folder that was linked for you. So I'm going to open that up in Arduino. Thank you, Windows. So I'm going to open that up in Arduino IDE. And I won't need my Finder window anymore. And what it's got is it's going to bring that up again. I'm going to close this other one. I don't know why it decided to not follow my preferences. So we'll go ahead and change those again. Make them a little bigger so we can see everything. Now this is an incomplete file. You're not going to be able to just hit play right away and upload it to the Arduino. We're going to have to make some changes. Those changes are highlighted in the guided activity. So the very first thing we're going to want to do is for this file, we're going to need to include some library files. And before we even write any code, we're going to need to make sure those library files are in the right place on our computer. So I'm going to open up two windows just so I can see what I'm doing. I've got two file explorers. The first one is set up, it's in my documents folder. This is where Arduino puts its folder by default. So unless you've moved it somewhere else, you should look under your documents. And there's going to be a folder called Arduino. When I click into that, I'm going to have, if you've made any other sketches, and then there's also going to be a folder called libraries. We want to be in the folder called libraries. Something you also should have downloaded from the resource file that was linked to you on the Google Drive is there are two library folders. Once you've unzipped them, there's going to be one that says One Wire Master and another that says Arduino Temperature Control Library Master. Both of those you need to make sure are put in this Arduino library file. So once those have been moved over, you're going to be ready to go and start programming. What a library is it's just a resource of a bunch of different code that's going to let us have access to it when we write our program. We don't need to mess with any of the files inside these folders. There's a bunch of things in there. We don't need to do anything with them. Just kind of make sure they're in the right place. Now we're going to start writing some program. So the first thing we need to do is tell our sketch, hey, I want to include these library files. So we're going to start off with include. It's going to be written just like this. It's the same thing that's in our document if we're following in the guided activity. You're going to type one wire .h inside these brackets, and then I'm also going to include a file that is called Dallas temperature. This is going to let us have access to certain code that's already in here that somebody else has wrote for us. That's the great thing about library files is we don't have to write a whole bunch of code from scratch. This is going to let us use something that somebody else has already created and put it to use in our program. Next thing we're going to do, now that we've got that ready, is one important definition. So we've already had the line started for you here on line 4. It's going to say, hey, define one wire bus. And what this refers to is the signal wire coming off of your temperature probe. So in your setup, you made sure to plug that into an Arduino. If you followed the guide, we plugged it into port 5. It doesn't have to be in port 5 though. It can go in any port of those digital ports, so long as you make sure that port number corresponds to what you're about to type in the code. Mine's plugged into 5, so I'm going to type in 5. Now, anywhere you see in the code the phrase one wire bus, it's going to replace with a number 5. So that's what's going on here on line 6. It's referring to that. It's creating an object called of type one wire. Don't worry about what that means. For what we're doing here today, you don't need to understand exactly what's going on line 6 and 7. Just know they're going to let us do some cool stuff in taking the temperature using our probe. Next thing we want to do is we want to create two variables that are going to we're going to use them everywhere. So we're going to declare and initialize two variables for temperature. We're going to make one for Celsius and one for Fahrenheit. The first one in the guide is just set up for you. So it's going to be a type double. If you've watched the other videos, you know that a type double is a floating point number. That means it has decimal points. It can be negative, it can be positive, but most importantly, it's got decimal points. And we know our temperature is not going to be a perfect whole number all the time. So I'm going to call this one Celsius, and I'm going to go ahead and for right now initialize it to be 0. I'm not reading anything, it just gives it kind of a value so it doesn't have anything funny in it. We also know is we need to make one called Fahrenheit. Using what we know, I know it needs to look pretty much the same. So it's going to be double. It's going to be called Fahrenheit. I'm going to also set it to be 0. These being before the setup section, before the loop, are going to let us use them anywhere. What we've got to do next is we've got to work in our setup. Because so in this program, we're looking to use some sensors, and we're also looking to use our serial monitor. That way we can actually read what the temperature is. The Arduino is still going to read the temperature. It can still make outputs accordingly, even if we can't read what they are. But right now I don't have anything else set up. Later on, maybe you can add some LEDs and write your code so that way those light up based on certain temperatures. For the moment though, we're relying on that serial monitor to tell us what that number actually is. So here in our setup section, I want to start my serial monitor. So that's serial with a capital S, that matters very much, .begin, and then the number we're going to put in is 9600. This 9600 refers to a baud rate. That's the number of times communication is happening between the computer and the Arduino per second. So it's pretty fast, but it's a computer and it can handle it. And then we're also going to do something. We're going to add the line of code called sensors.begin. And this is something important that just lets us use our temperature probe. It's referring back to our library files, gets that ready to go. What we're looking for next is we got a few more things to finish in our program. Down here in our loop section, we've got an incomplete line 22 and line 24. Right now, if you read it, so what's happening is we are requesting our temperatures from our probe. The Celsius variable is getting filled by what's coming off of the sensor. It's getting its temperature, and then the Fahrenheit, we are using a conversion formula just to go from Celsius to Fahrenheit. So that way we have both. It makes it a little easier for those of us who are more familiar with Fahrenheit. Here in line 22, we want to print the variable that goes with the serial print statement that came before it. It's the C, so I'm going to put in Celsius. I am not very good at spelling. Fahrenheit 24, we want to do the same thing. Fahrenheit. We've also got is this delay because we don't need to update our temperature 9,600 times per minute. We can put a delay in there, slow it down a little bit. We don't need to print this out that fast. Now before we run our program, we're going to open our serial monitor so that way we can actually be ready to read and see those temperatures when they come out. Now we're ready to go, provided we didn't make any errors. I'm going to go ahead and click verify first, make sure I didn't make any silly mistakes. I'm going to wait for it to compile. Okay, what it does is it tells you, hey, by the way, this file is this certain size. It's a little big. It takes up 18% of the space available. Just some extra information, not really important for us in this instance. I'm not worried about taking up too much space. I want to go ahead and upload. And this is the part where it's actually sending it to our Arduino, and it's going to automatically start running once it's there. So we look over on our serial monitor. I've now got temperatures, and it's about 72.5 degrees where my temperature probe is. So what I'm going to do is I'm going to go ahead and move it over. See, I've got my temperature probe. I'm going to put it in my hand, see if I can warm it up a little bit, see if we can get those temperatures to rise. And it looks like it is. So if I held it for quite a while, we're going to see that increase. We're still going up. That's good. I've also got, just for an example, I got a bottle of water here. It came out of the refrigerator, so it's still pretty cold. Make sure our thermometer is working properly. And dunk that in there. So it does have a little bit of delay. It's got some thermal resistance. It can hold on to that. So we'll get in there. It's dropping down though. That's into my nice cold beverage. My cold water. It's going down. Water, we're still, let's see, south of 60 degrees. Okay. A little chilly. Point is, my temperature probe is working. My very quick sketch here is functioning the way it should. It's reporting out temperatures. Now that's not very exciting. We can do a lot cooler stuff than just report out temperatures. So I'm going to move my thermometer off to the side. I don't need it right now. This is going to keep running until I remove power from an Arduino. So right now, it can keep running. I'm not too worried about it. What we're going to do is we're going to make some conditional statements. So that way, only certain things get printed to our serial monitor. And then later on, maybe if you wanted to have certain things happen with other outputs in our Arduino, these are only going to happen in a certain instance. So what I'm going to do right now is I'm going to go ahead and comment out lines 21 to 24 because I don't want it to print this C number, F number message anymore. Cool thing is, if I highlight all of them and use Control and then the question mark button, which is also our / button for the comment, this is going to automatically add in comments for each of those. I could do it individually line by line. I could use a multi-line comment. This is just a really efficient way though to toggle these on and off. I don't want to delete them because maybe one day I want to come back to them and test those. Who knows? What I want to do next is write our conditional statement. If we remember how those work out, we're going to start with an if-else statement. How that works is we have if, and then we have a Boolean statement, and Boolean is true or false only. So yes, no, true, false, 1, 0. something like that. And then inside there is going to be some statement that I want to run. First statement I'm going to do is I'm going to go ahead and just write it so that if it is less than freezing, because if you're following an guided activity, you want to do a couple of things. I want to be able to read, okay, is my temperature probe being something less than freezing? Is it, you know, from freezing to human body temperature? Is it in that body temperature range? Is it between body temperature and boiling? And is it greater than boiling? So let's start with that. First one, we just start with the word if. From there, I'm going to use my open parentheses, and then I'm going to say, what am I going to compare? Well, I'm going to compare it using Celsius, because I don't feel like doing all the crazy numbers that are in Fahrenheit. Celsius is really nice. I've got zeros. I've got 100. Lines up really well. When I do less than, equal, is it going to be a less than sign followed by an equal sign? Pretty simple. Less than equal to 0 for its freezing. Open curly bracket. When I hit enter to go to the next line, it will auto-generate that closing curly bracket for the if statement, which is really convenient. So on the inside, I'm going to write a special message since it's freezing. And that message is going to be freezing. I'm going to leave a space so that way when I print the next part of my message, I do want to print what the temperature is. Because, you know, if we're less than 0, I might care about just how cold it is. And I'm going to go ahead and print that temperature. So right now, let's verify, make sure I didn't screw anything up. We're good. We'll upload. You'll notice while we're uploading, of course, the Arduino is not running any code. It's the entire code is being rewritten. And it's actually playing right now. Because we don't see anything happening, which is kind of boring. But remember, we wrote an if statement saying, hey, if it's less than freezing, print this message that it's freezing and what the temperature is. It's pretty warm in my room. It's not less than freezing. My temperature is definitely above 0 degrees Celsius. I don't have anything quite that cold right now. So what we can do, just to check that what we wrote is working, we can add this an else. Same thing. I write the word else. Notice on line 28, it's in that curly bracket for the first F, the if statement. It's on that one. It's not on the next line. Hit enter, auto generates the next one. And right now, I'm just going to go ahead, print whatever temperature it is, just so we know that our Arduino is running. We're going to eventually go ahead and change that. For now, it's going to let us know, hey, things are running and they're working. It's not just I'm getting a blank screen because all of a sudden I lost connection or something. Give it a minute, and now it's starting to read our temperature again. So we have written a successful test case here. If we want to test again, you know, I could check, say, hey, maybe it's less than 60 degrees just for right now. Not 60. That's 60 Fahrenheit. I don't remember what my beverage was. You can test it, put in your own numbers, see what sort of numbers you're looking for if you want to test. Generally speaking, unless you made some crazy code error, this number is going to work, and if it were freezing, it would actually tell me. What I'm going to do next, so our next one is we wanted to go between freezing and body temperature. So body temperature in Celsius, is about 36.5 degrees. We're going to call it 36 to that 38 range. What I'm going to do is I'm going to create an else if. So for right now, let's kind of put him off to the side. Instead of typing the word else, I've typed in else if. And because I have that if, I do need some sort of condition. Well, I care right now if it is less than 36 degrees. So we're in that it's warmer than freezing, but not that body temperature range yet. So we're going to open curly bracket, close curly bracket, and then I'm going to go ahead and bring this on up so it's sitting on that same line as that closing curly bracket from the else if. Normally you would write this top to bottom. You wouldn't have this floating else you have to keep messing with. This just is so we can make sure our Arduino keeps running. So I'm going to do a serial.print. I'm going to write some sort of message to the extent that it is cooler than body temperature. I'm putting this space So that way I'll show you in the message a little bit later. Otherwise, the next thing it prints, the temperature, would come right after the period and it wouldn't look very good. And then we are going to do a serial.print line. That's an ln for Celsius. So that way it also, again, reports out that temperature. If you'll notice a little different here where it says serial.print, the next item comes on the same line. So I can upload this again as well. Oh no. Oh, see, if you read your error messages, and don't be silly like me, it's going to say, hey, it expected a semicolon before serial. So what's happening? On line 29, I forgot my semicolon on the end of the line. Gotta have those. That's the law. So we'll try that again. So right now, my temperature probe is reading that it is currently cooler than body temperature and that it is 21.12 degrees Celsius. Just hanging out here. Now, as much as I try, I'm not going to be able to get this thing up to 90 degrees right now. 91 degrees, give or take Fahrenheit. So I'm going to be stuck with that cooler than body temperature message for quite a while. I don't have anything warmer. This is why, this is the example here. Later on, you can write in and put in your own temperatures, your own messages. Maybe you have something you want to measure where it has this really ideal temperature range, an okay temperature range, and you can kind of print those out and kind of give warnings, whatever custom messages that you want to add. This is just kind of the example we've got here for you. Next thing, of course, what I want to do, we want to add something for whether or not is in that body temperature range. So I'm going to add another else if in. Celsius. Now I've already got my lower bound here. So what I'm going to do is just do the upper bound, which is about 38, give or take, semicolon, bring this other else back. If you think about it, it's like, wait a minute, body temperature is 36 to 38. She only checked if it's less than 38. She's going to write that it's body temperature. You are absolutely correct. Oh, that's not where I want to be typing. Because if you think about it, these write an if statement checks top to bottom. So in my program here, the first thing is going to check, hey, is it less than freezing? If it is, it's going to do that. If it's not, it's going to say, hey, is it less than 36? And if it's not, it's going to say, hey, are you less than 38? Well, if it's true, I know if it's less than 38, it's going to be greater than 36. Otherwise, it couldn't have gotten here. So that's how I don't have to worry about whether or not it's greater than 36. I know if this is checking right here, it's already going to be higher than 36. So we'll do the same thing we've done last couple times. We're going to also print what the current temperature is. We'll just keep using that Celsius variable. If you also want to add in Fahrenheit, you can do that too. Maybe you want to know. You can make this as custom as you want. I can upload and test it again, but as we established last time, I can't get that warm right now. I don't have that kind of ability to do so. It's going to keep telling me we're cooler than body temperature, which it is. Last thing, let's see, we want to do a couple more. We want to check if we're greater than body temperature, but colder than boiling. So I'm going to do sort of the same thing. Else if Celsius less than boiling. This is why I picked, 100's just a really nice number. Sure, I could use Fahrenheit and use 212. It's all about whatever you want to do. Celsius is convenient, Fahrenheit's convenient, however you want to do it. Go ahead and type our serial.print. Get a lot of experience using these. This is going to be warmer than body temperature. Green. There we go. Report out. What's our temperature? Same thing as before. I'm going to go ahead and actually move on and just add that last boiling one. Here's the crazy thing. We already have it. We don't even need to add in an else if for it. Because remember, these if statements read top to bottom. What we've got is it less than 0. Then it means it's freezing. If it moves on, we know it's higher than 0. It's going to check, hey, are you less than 36? If it is, it's going to print out what's inside. If it's not, it's going to say, hey, were you less than 38? Same deal. If it's not less than 38, next thing it's going to do is check, hey, are you less than 100? If it is, it's going to print this. If it is greater than 100 or equal to 100, it's going to be like, hey, you're boiling. I don't need to check if it's greater than 100. Anything that's not less than 100 is equal to or greater than 100. So anything else must be boiling. So I'm just going to use a plain old else. Boiling. That is not the word boiling. That's the word boiling. Now my program is kind of complete for this example here. Let's see. It's going to keep telling me it's cooler than body temperature. And unfortunately right now, I don't have a way to test that it's boiling. But I can check my code. So what I'll do for right now is I'm just going to mess with all these numbers. Let's see. I bet I can get to 15. We'll make a really narrow range here. I'm just going to mess with all these numbers. Our messages won't have anything to do with reality. But they will have everything to do with the code that I wrote. So I did, 15, 20, 24, 26, and anything higher than 26. It's still going to say that we're cooler than body temperature, freezing, warmer, boiling. We know that's not obviously the case, but I'm going to at least check to see if I can change these messages. So we can see the first change right away. That body temperature range right now is if we're less than 24. Oh, it's a little bit higher, so okay, we're pretty good. Let's see if I can warm it up a little bit. See if I can I might be able to get higher than 26. I hope. Hold it long enough. We're just trying to check whether or not things are going okay. It says, hey, warmer than body temperature. Yep, it's greater than 24, but less than 26. So we're warmer than body temperature, and if I can get above 26, right now it's going to say boiling. Again, we know this is not true. We're not actually boiling, but it was making sure our code works based on the numbers we put in. And you can imagine maybe you want a custom message based on each thing. Speaking of those custom messages, we know that we need a computer to use the serial monitor. But in Arduino, that's something we can plug into a wall and just have it connected to a sensor. And we may not always have something, some sort of visual. We don't want to have access to the serial monitor. We still want to make sure our program works and have some sort of visual feedback. So what I'm going to do, I'm going to go first, put everything back the way they're supposed to be based on body temperatures and what all not. Everything now corresponds back to reality. Remember, the Arduino is still running, so my serial monitor is going to keep on with that old code. This here has not been uploaded yet, so it hasn't affected the serial monitor itself. I think I put my probe somewhere warm. It'll cool off eventually. It's good at holding heat, so unless you change it rapidly to something, it's not going to just dissipate very quickly. So maybe I want to build a circuit with some LEDs based on each temperature range, and then it'll kind of like fill them up based on our temperature, kind of like a thermometer would, visually. So what I would need to do is set up our code just the way we've done in a previous activity, making sure it's ready to be used for an LED. So we'd need to put in our pin mode. Say I was putting it into port, I don't know, we'll use port 8. I'll put my LED there. We want to make sure it's set up as an output. Got to remember to do our setup. And then maybe, I don't want any LEDs to come on if, we're at freezing. I want it to be the very bottom of our temperature scale. So what I'm going to do is before this if statement runs, I am going to add in the code to turn off our LED. So we are going to use, caps lock is on, digital write. That's how we send information out to our pin. And get it on pin 8. We're going to be, I'm turning it off, low. So it's low now. And the only time I want to turn it on, this very first LED that I'm going to add, is going to be in that first slightly warmer than our bottom condition. So it's going to go in here. I can put as many things inside this else if I want. And I am going to turn it on if it's warmer. Now you bet, like, well, wait a minute, it's just going to turn off again every time. Because remember, we are in a loop. But it's going to process so fast that we won't ever see it turning off. It's just going to keep turning on. Okay? So that would happen if we were less than body temperature. Right now, the only time that LED is ever going to turn on is if we're warmer than freezing, but colder than 38 degrees Celsius. If I wanted to make one that's really cool in the real world, what I would do is I would have 4 or 5 LEDs, since I've got 5 conditions. I think 1, 2, 3, 4, 5. You know, I can have them each fill up. I'll do 4, just so that way they're all empty and they're all off when we're freezing, and then we'll kind of add them. You can imagine we stack them up. So what I would do, add a few more pin modes. For the next one, I'll use the next couple, and I'm going to copy and paste because I am lazy, and copy and pasting is your friend. Now all I'm going to do is change the numbers. Now 8, 9, 10, and 11 are being used. These are going to be all corresponding to my LEDs. I'm going to do the same trick I did here on line 29. Oopsies. I'm going to do pin 9, 10, and 11. We're always going to have the default case being off. And then based on what the temperature is reading, we're going to turn them back on. So on this first case, I'm just going to go ahead and copy all of these. We only wanted this first one to be on because, you know, we're not quite full up. The next one, we're going to want 2 to be on. So I put in 2 of these really messily. And I want 8 to be on and 9 to be on because I wanted to build it like a thermometer. 8, now 8 and 9. Okay, well, the next one, I want it to be 8, 9, and 10, right? So we'll just get rid of the extra one. Copy and pasting helps you move through really quickly. You don't have to spend a lot of time typing. So now we have 8, 9, and 10. And then we know we're going up to 11 for the last one. So we'll paste those in there. 10 and 11. Now, of course, I gotta change all of these to high now. Probably should have done that before I copied and pasted. I wasn't paying enough attention. So I copy and pasted the word high. I'll just go in there and change all of those. It's not a big deal. Now they're all set up. So if it's freezing, I won't have any LEDs come on. If it's warmer than freezing, but not to human body temperature yet, it's going to turn on just one LED. And then next range, a little bit warmer. Next range, a little more lights each time. So you imagine if you have a lot of LEDs, you could do maybe every 10 degrees. And you get kind of a rough idea thermometer you could create. I'll go ahead and verify. I'm not going to upload this because right now I don't have the LEDs actually hooked up. But if you've done the other activities, you know how to do that. We can just add those in addition. You can add as many ports as we've got on this Arduino. We can add as many things as we want. Our code's ready to go. We'll add just for fun. I think that's kind of something cool to add there. We've got lights. We've got messages. We can change them however we want. You kind of see you've now got this template. With these else ifs, if I wanted to add another range, I would just break in there, add another one, add another condition, and just keep going until I'm happy with all my conditions. Maybe you have a lot of ranges. Maybe you don't need 5 sections. Then you get rid of one. You also don't need an else condition. Maybe you don't care if it's greater than 100. That seems dangerous. But maybe you don't care. And you could just delete this else entirely, and it just wouldn't ever do anything if it was greater than 100. It's also an option. And that kind of brings us to the end of this video. I hope you've been able to follow along. Hope you've got your system running. And thanks for watching.